Greetings everybody. So I'll make this video to show you 3 examples regarding calculations in the normal distribution. Okay, so this one's the simplest, so I'll start here. It says find the area under the standard normal curve to the right of 1.59. Now this is the most straightforward kind of thing that we'll do with the normal distribution. I know that right here it says you can answer this question by looking at something called the standard normal table, and I guess you could do it that way if you wanted to. It's not how I'm going to show you how to do it, because within MyMathLab we have StatCrunch, and it makes all of these things easier to do and more accurate. Okay, so I won't do it this way with the standard normal table. If I'd like to use StatCrunch, then I'll open StatCrunch from within MyMathLab. I'll go to Stat, Calculators, and then Normal to get the normal distribution. If it says that I'm using the standard normal curve, that is this normal distribution with a mean of 0 and a standard deviation of 1. And you'll find that that's the way it opens. When you open this, it's the standard normal. From there, if I want to find the area to the right of whatever number's given, then I can select this inequality portion to be left or right. Okay, so here it's set to right, which looks like greater than, and here it's set to left, which looks like left than. So we want to set to right, okay, and it says specifically to the right of 1.59. All I have to do is type in right there 1.59, and then it draws me a picture. There's the area to the right of 1.59, which is right there. That answer, that area, is 0.0559174. If you take that number and you round it to 4 decimal places, according to these instructions, look, it says round to 4 decimal places. If I take that right there, round it to 4 decimal places, I'll get what you see here, 0.0559. Okay, so this is the most direct, basic thing that we do with the normal distribution, is find areas on it, left or right from certain numbers. Okay, so we'll start there. This next one is the same, but it's worded a little bit different, and I think there's one other consideration involved. It says, can you find the area under the standard normal curve? So wait, that is this one, right? That's the normal curve with a mean of 0 and a standard deviation of 1. Okay, so we're going to look at that. To the left of negative 2.63 and also to the right of 2.63. So here's the way that works. The normal distribution is a mirror image of itself right down the middle. What I mean is, if you cut it right down the middle right there, what you see on one side looks identical to the other. They're mirror images of each other. So what you can do is this. The area to the left of negative 2.63 is the same as the area to the right of positive 2.63. So these are the same. You can just find one of them and double it, and that will be your answer. Find either one of these. Set this thing up, left or right, find either one of these, double it to get your answer. So how about this? I have it set to right already. How about I put 2.63 in here, and what it'll give me is the area to the right of 2.63. And that turns out to be 0.042924. If I take that number that you see right there, and if I wanted to use my calculator, multiply it times 2, you'll get this number, 0.0086, rounded to 4 decimal places. Take this, double it, get that. Okay? Now you could use that normal calculator to find either one of these. Just know that they're going to be the same. Double it to get your answer. Now if these numbers weren't different, I'd have to find them each individually and add them together. But at least that's not the case here, and I can do it the way that I showed you. Okay, so next one. It says this, that we have a SAT test scores that happen to have a normal distribution. And most things that you measure about people are normally distributed. Heights, weights, IQs, how fast they can run, so on and so forth. Test scores, I would expect most of that stuff to be normally distributed, meaning most people are going to be somewhere in the middle. Very few will be much higher than that or much lower than that. So most people are going to score near the average, whatever the average is. Very few will score significantly higher, and very few will score significantly lower. Okay. So, okay, let's answer from there. I got my normal calculator open. I'll be able to do this question with this somehow. So how about this? It tells me that I'm working with a normal distribution that has a mean of 514 and a standard deviation of 109. So I'll go ahead and put that in. So 514 for the mean, standard deviation 109. And maybe we don't know what we're going to do with that yet, but that's at least the necessary information for the question. All right. Now, it says in part A, what percentage of SAT scores would you expect to be less than 650? Okay, well, we can do that like this. We'll use StatCrunch. We'll open the normal distribution. Okay, I got that open already. I'll put in the mean and standard deviation. Already did that too. And if I want to know the percentage of scores that we would expect to be less than 650, I'll set this up to measure left, and I'll put in 650. See, and our picture shows us the area left of 650. I just set that to less than to get it to do that. And I get this number right here, 0.89393071. Okay? All right. So that's our answer, 0.89393. So I wrote down some of that number. It does say to express our answer as a percent though. So how do you make that a percent? Like that's our portion that's going to score less than 650. It'd be more natural to say that as a percent. So if we move the decimal right 2 spaces, we get a percent. So that means 89.393%. Okay? I would round that to 2 decimal places as it says there. And that'd be my answer, 89.39%. Now you might wonder, why does it say 89.44%? I just used this. I did it the right way. I got 89.39. So that number there in the answer looks a little different. Why is that? Well, we have the option of using the standard normal table. You could do it that way if you wanted to. You'll get this number if you do that. But using the normal table is not as accurate as this. So that's why you get slightly different answers. As long as you're using either the normal table or StatCrunch correctly, MyMathLab will accept both of them and you don't need to worry. But I think most people will use the normal calculator. You can trust that answer so long as you configure this the right way. Okay, so even though that looks a little bit different than the answer by default in MyMathLab, it is correct, 89.39%, 2 decimal places. What about this next one? How many SAT scores would you expect to be greater than 575? Now, I noticed A and B sound like they're asking the same thing. How many scores less than 650? How many scores greater than 575? The difference is, part A, it says, what percent of students do you think would score less than 650? Part B, it's saying, how many students do you think would score greater than 575? See the difference there? If I say 89% of students are going to score less than 650, that doesn't tell me how many actually made that score. It just tells me the percentage. So in part B, I want to know how many students, okay? But we can answer it the same as part A. So we'll set up our normal calculator the same way, mean 514, standard deviation 109. And first I'll do this. I'll say, well, the calculator here will tell me the percentage that's going to score less than or greater than or whatever for some given base score. So I want to find, well, what percentage of students would score greater than 575? So I'll set this thing up to do this and put in 575. Okay? And it gives me this number, 0.28786. So here's what we think about that. The area greater than 575, 0.28786, which means 28.786%. So with just this right here, going about it the same way that I did part A, I say, okay, well, you want to know how many students score greater than 575? 28.786%. That's how many, okay? But I'm asked to find not the percentage, but how many actual students. So if you tell me that 1,000 students took the test, then my answer to B will be 28.786% of 1,000. That's how many students are going to make that score. Okay, so the way I would calculate 28.786% of 1,000 is to multiply 0.28786 times 1,000, and I'll get 287.86. Okay, so that's how many students are going to score greater than 575. It says to round to the nearest whole number, so as I got my answer to be 287.86, rounding that to the nearest whole number is 288. Okay, because it doesn't make a whole lot of sense to say 0.86 students scored this or that. Okay, so we'll round it to the nearest whole number. 287.8 rounds to 288, and that's the answer that you see here. Okay, so that's how we can use normal distributions and StatCrunch to answer a variety of questions. If you really want to use the table, you could do that, but I don't see any need to do it that way, and at least for now I'm not recommending it because I don't see any advantage.